Yeah, welcome back to my channel. I'm in my humble self, Edu Hader. Please, like I've always said, kindly subscribe, like, and you make your comments. And of course, share with friends, students, and teachers, as the case may be. Now, you've been following me on the series on differential equations. So, we've spoken about the techniques involved in solving questions relating to differential calculus. Then we've actually done the application. Yes, I've treated that of gradients, treated that of minimum, maximum, and critical point. Yes. So what we left with the rate of change. So there, now we've spoken with all the techniques involved in solving those problems on differential calculus. Now we have implicit functions to deal with. If we have, what the meaning of implicit, it actually means indirectly. So you're having a function such that you're having two variables there. You have x and y, and you have to look for the y, the x, and to differentiate same function with respect to x. So we go indirectly, and that is implicitly. So how do we solve? Let's go. Now the principle is this: there are actually two or more ways to go about this. Well, I will most likely stick to one. Note this: I can decide to solve this implicitly by differentiating. As I'm differentiating, I'm holding one constant, I'm solving the other, and I can now I will put whenever I differentiate y, I'll be including the y dx. While I differentiate x, I will leave it. I will not add any form of derivative to it. But that's the method. I can equally go by the second method, which I will apply in this problem. I can, each time I differentiate y, I add the y to it, which means I'm differentiating with y. I'm solving indirectly. So that must be added. The y, and whenever I'm differentiating x, I add the x. And eventually, I will collect like terms. Eventually, I have my dy dx. So I'm done. So let's go by that method. We have this. Y squared. To differentiate y, what do we have? We are differentiating. I look for the y dx, right? So I don't need to write that. So for differentiating y, you have 2y, then my dy is added. Are you seeing what I'm doing? So it will be equal to, I have 2x dx plus, now this is xy. We have x, we have y. So what do? What we will do is this. Differentiate x. We differentiate x normally, you're supposed to have what? You're supposed to have 1. But y is a constant. That will be y dx. You get? Then if you differentiate, that will be plus. You differentiate y its own too. So that will be x dy. Do you see that? So that is what you will do throughout. Now you collect like terms. Where are the dy families? Bring them together. Where are the dx family? Put them to the other side. You get? So now we have 2y. The y, when I have dy here, we have dy here. So minus x dy, that can be equal to 2x dx plus y dx. So what do we have here now? We have dy open bracket 2y minus x, and that can be equal to dx open bracket 2x plus y. You get that? So I can now say the y dx, this divided by this, and divided to by dx. You get? So I have this times this still equal to this. I want to take it gradually so that you get what I'm doing. You get? So now I can say 2y minus x. That can be equal to 2x plus y. Then I can eventually say my dy dx can be equal to what? I have 2x plus y upon I have 2y minus x. Do you get that? So that's how you will just solve. Straightforward and simple. So that's how we go. Let's go with example 2. Now, there are some questions in differential calculus or under the application of differentiation itself that will involve or that will imply that we require rather that we use implicit functions. So always watch them out. There are some questions that you need to solve implicitly before you get to the point where you need the solution. 2. Differentiate this. You have 9y squared dy minus 4y dy plus what? Differentiate with respect to y first. So we have 3x dy, then plus 3y dx. Are you getting it? So if you differentiate, I don't know if you understand what I did here. I did it in the previous one. So we have 3 is a constant. You are not differentiating it. X or x. Let's assume we have xy here. So you are differentiating this with respect to x. Normally, if you differentiate 3x, the answer will be 3, right? But because you are taking y as a constant, just like y is the only thing you are differentiating, you are taking y and 3 to be a constant. So 3 and y, you are not touching them. They have 3. Differentiate x, you have 1. So you still have 3y what dx. The same if you are differentiating y. Do you get? So that plus 0. This, if you differentiate a constant, is 0. So that is equal to 0. Do you get that? So now you can take some to that side, bring some to this side. Let's leave our dy's here. Let's take our dx to the right hand side. So we have 9y squared dy minus 4y dy plus 3x dy. That will be equal to minus 3y dx. Do you get that? So here I can have my dy, open a bracket, you have 9y squared minus 4y plus 3x. And that can be equals to what? Dx, open a bracket of minus 3y. Are you seeing that? So we can now say we have our dy dx. Of course, just like we did in the previous one. So this comes here. So you have minus 3y upon, we have 9y squared minus 4y plus 3x. When you close the bracket, we are done with this 2. Example 3. So upon all these, I wish with all these examples you're able to solve more questions. And if you have any question or you are stuck when you're solving, just make it known in the comment section on my channel. I will always reply you. If you have a question you want to solve, send it there. I will get it solved for you. We are working for each other. So here we have now x squared y plus this. Okay, so we have, let's differentiate with respect to x first. So we have 2x y dx plus x squared dy. Yes, if we differentiate with respect to y, this is 1. Differentiate y, you have 1. This is a constant, so x squared dy. Then you have plus. Here, what do we have? Differentiate with respect to x. So you have 3y squared dx. Are you getting that? So we have then with respect to y plus 6x y dy. Yes, 6x. 2 multiplies this. You have 6x. Then y reduced by 1. Then dy. Then we'll move on. What do we have again? Plus, differentiate this. You have with respect to x, you have 6y dx plus 6x dy. That becomes 0. Differentiating a constant, that turns to 0. You get that? So here now, let our dy be at the right hand side, our dx at the left hand side. So we have our dy family. We have x squared, and put the y outside already. So x squared plus 6xy and plus 6x. You get that? And that can be equal to what? Oh, bless you. So you have this, the x group comes here. So you have the x, open bracket. I can have a minus outside. I have minus. Then we have 3y squared. Because everything coming here, they'll be negative. You get? So you have 3y squared plus 2xy dx plus 6y. You get this? So this can also be equal to what? Dy dx can be equal to this. You have minus, open bracket, 3y squared. Okay, you have minus y. 3y plus 2x plus 6. Everything upon you have x. Open bracket, what? X plus 6y plus 6. So this is what our dy dx will give us. Do you get that? Please go through the video while you are solving. Ensure as you are solving, you are equally, while you are watching the video, ensure you are also solving yourself. After the video, go through how it on paper, solve yourself, and make sure you get it deeply and in-depthly. If you have any question, any observation, may have a correction, of course, make it known in the comment section. I would appreciate it. I would love to hear from you. Please help me share this video, people. Thank you very much. See you some other time. Bye for now.